So kind of related to that chart were these three bottles, okay? These three kind of systems. Notice we have the warmest to the coldest, okay? And the first row, all that's telling us is from the table. At the temperatures of 20, 10, and 0, how much do we need to reach saturation? Okay, the middle one is telling us how much water there is, vapor, floating around in there. Okay, and the bottom one was that percent relative humidity. Basically, when you guys have been doing your weather logs, if somebody says it's 80% relative humidity out there, oh man. So that means that basically it's right at about 8 parts out of 10 parts, or 0.8, how much water vapor it can hold, the air can hold at that temperature. Okay. So then we did like a little division of how much water there was, how much it could hold, 7, 14, 50% relative humidity. This middle temperature, we reached saturation, 100% relative humidity. So when we cooled it down, we got a puddle. Okay, so that's kind of what we talked about on Monday. Okay, so this, I think, did we do this slide too?
No.
Okay.
Before this, the bottom line.
Okay, so I'm going to let you kind of fill in this blank, and I'm going to pull up this little video. Okay, so humidity. Okay. Humidity is the amount of water vapor in the air. Okay. And we can change the amount of water vapor in the air. We can, oh, sorry, this is relative humidity. If we want to get closer to 100% relative humidity, we can do one of two things. We can cool it down, okay, or we can add more water vapor. Yeah. So let's see if this will play for us. It should. And underneath, you can kind of see, well, your doors swell, okay, when it's humid outside, okay, and they get smaller when in the low humidity. Let's go down a little bit. Okay, when it's dry, when it's maybe dry in your house or something, cats are licking themselves. Our cats are doing that all the time. Okay. No, you have a dog.
Yeah. He does it too.
But humidity, I think this is interesting. Actually, it's, we talked about sunrises and sunsets. Humidity can actually change kind of their appearance, their general appearance. Okay. So that's just for you to keep. We might be referring to that later. So where's my little video? Maybe it's coming up. Okay. So this actually, if you want to write on here homework, you can, because this one, I know and I handed you out the homework sheet today. So you'll need to use this figure for one of your homework questions. So if you look at it, basically it's saying this is the temperature, okay, from sunrise. So it's kind of near the equinoxes. So sunrise is 6 a.m., sunset about 6 p.m. Anyway, so we have notice the peak temperature there, it's looking like about 5 p.m., isn't it? Okay. So assuming that you have the same amount of water vapor, okay, this is what your relative humidity is. So basically it's saying at the lowest temperature, you're going to have the highest relative humidity. And at the highest temperature, I know it's going to feel oppressive, but it feels backwards. But when the temperature is highest, the air can hold more water vapor. So when you do the math, okay, basically you're not bumping up at 100% relative humidity, okay?
It's almost confusing because you just think of warm air, it holds more water, so you would think it'd be more humid, but since cold air can't hold as much, then it...
Right. Then this is kind of a little deceiving because it's assuming that with those warmer temperatures, you're not going to have any more liquid water going into the air, which that's not entirely sure. Okay, but assuming that there's no more extra liquid going into vapor, at your high temperatures, actually, that's going to be your lowest relative humidity. It does seem a little backwards.
Mm-hmm. A lot of things in weather.
Yeah. exactly. So if you crank down the temperature, your relative humidity goes up. And actually that comes to what we call dew point temperatures. So if you've been doing your weather log, you've been recording the temperature at which you would expect dew or condensation to occur. Put another way, in kind of what we've been talking about, at the dew point temperature, you reach 100% relative humidity. That's it. Okay. So we'll see, this should be a video. Should be. Shattering or anything, but like if you have a cold beverage and your beverage is sweating, okay, that's not because your beverage is going through your glass. That basically is water vapor that's condensing, okay? So it basically, in the vicinity of that glass, it has reached at least, or not colder than the dew point temperature. So kind of around there. I just think that's neat. Well, yeah. So my thing is, like if you go to Arizona where the humidity is usually less, okay, do their beverages sweat? I don't think so. Less likely. Okay. That's my thoughts.
Probably don't sell a lot of koozies over there.
They probably don't sell a lot of koozies. Exactly. So this is kind of along the lines of dew point temperatures and how you might be feeling about your dew point temperatures. So the dew point temperature right now is -7, right? Okay. So we're kind of like in relatively dry conditions. If your dew point temperature is pretty high, remember that dew point temperatures are always lower than your current temperature. So if your dew point temperature is 55 degrees Fahrenheit, then you must be warmer than 55 degrees Fahrenheit. Okay. So dew point temperature of 65 degrees Fahrenheit in the summertime, actually that's going to be one of our kind of muggy days around here. Okay. In the rainforests, high humidity, high temperatures. Okay, a lot of times they only have to go, their dew point temperatures are in excess of 70 degrees. So, this is a map just kind of showing you these temperatures are not the surface temperatures. These temperatures are how low you need to go in order to get, did you get the word you needed? Water vapor. Those temperatures are how low you need to go in order to get dew to form. Well, that's okay. That's about how far I want to go anyway.